Today I am going to show you why 7 is everywhere. Now already you know by the title that 7 is everywhere should be misleading, maybe a tricks, but no, mathematically it's correct, and that's what I am going to show you. Okay, so now let's jump into the series of the between the range. Like, hey, if we just talk about some 0 to 100, sorry, 0 to 10 first of all, then we know by our experience in this range 7 is only in one positions, which is 0 1 2 3 4 5 6 7, and that's the only 7. So in this range we can get only 1 7, right? So this is the number of 7s we can get from this range, right? This is the range. Now what about the 0 in between 0 to 100? So in between 0 to 100, you know, probably I have a draft here which can be useful, so just I'm showing you. Okay, so this is the draft what I have drawn. So in between 0 to 100, you can see that 7 to 97, everything contains a 7 digits, so it's literally 9, and then there is something else which contains 7 digits, which is 70 to 79. Alright, so 7 is there and 7 is there, which total sums up into 19. So it gives you the 19 sevens in between 0 and hundreds. And then if we continue this series, then we will get, it will be 0 to thousands, and we will get something 271. You can count up on your own selves. Okay, so now what I'm going to do is basically finding the probability. So the proportions, you can tell it proportions of the probability of finding 7s in the range. So I'm calling it's a probability, right? So it's kind of probability. So in between 0 to 100, 0 to 10, which is 10 digits, we just got 1 7. So it's 0 1 by 10, which will be 0.1. Now for this series, we got 19 sevens in the 100 digits, so it will be 0.19. And then in between 0 and thousands, it will be 271 digits, which contains 7s, and 271 divided by 1000, which gives us the probability of finding 7s in between this, which is 0.271. Alright, and now if we go further for the range 0 to 10,000s, probably you will find 0, which is 3439. You can count up it. So then it will be 3439 divided by 10,000s, which will be 0.3439. Now interestingly, you can find something interesting, very interesting, which gives me pleasure, obviously. So it's the fractions, the probability is really increasing over time, over the range. The more digits are over there, it will be increasing. Okay, so now what I have to do is basically I will find some similarity here. So the similarity is, if here is another draft what I have drawn before. So suppose kn, which is kn plus 1, which is I will tell it what is this later, but first I will call for kn. So kn is the number contains 7s in the range of 0 and between 10 to the power n. So if we call, if it's n equals to 3, then 10 to the power 3, which is 1000. So in between thousands we got 10 to the power n and kn, which is the number of sevens in the region, in the range of the 10 to the power n. Okay, so kn plus 1, which is the number we will get in the range between 10 to the power n plus 1. So it's a common formula, but now we have to multiply 9 with this to complete the thing. Now here is a very simple demonstrations why this formula is coming on. So let's see, if we just count 0 to thousands. Okay, so now 0 to 99 contains kn, which is obviously for 10 to the power, so for so kn for where n equals to 2, so we get, it's already, we know it's 19. Okay, so it will be kn, which is equals to 19. So it is 19. So in every 100 digits you will get kn equals to 19, except 700 to 799, because in between 700 to 799 every digits, which is 100 digits, which is for this 10 to the power n, contains 7. So basically 9 multiplied by 10 kn and then plus 10 to the power n, which is the formula here. Now it is a simple formula to evaluate for the next one, which is 0 to 1 million or 1 billion, whatever you want to find, it will be very easy. Now what I am going to show you, that if we just take some 4-digit number, which can be 0000, or if we just go for another number which is 1234 or 7123. So every number, you know, if it's 4-digit number, then the possibility of the combinations of this number should be this. So we can simply put 0 to 9 here, 0 to 9 here, 0 to 9 here, and 0 to 9 here, and combinations will be 10 multiplied by 10 multiplied by 10 multiplied by 10, which gives us 10 to the power 4. Now this is the number, the total number in between 10 to the power 4, which is absolutely correct. Now I want to find then how many numbers in the region 10 to the power 4, which is a 4-digit number, which does not contain sevens. Obviously it will be very easy to calculate, which is 9 multiplied by 9 multiplied by 9 multiplied by 9, which is basically 9 into 9 into 9 into 9, which gives us 9 to the power 4. So this is for the 4-digit number. If it's n-digit number, it will be 10 to the power n, and then 9 to the power, and then it will be subtracted. So here we can see, so the number which don't have the 9, so basically every number except this, which is 10 to the power n minus 9 to the power n, contains sevens. Okay, so this is the number which contains sevens, and this is also the same number, so we can simply equals to them. And then what I will do is basically divide with this region, which is 10 to the power n, and then you will see something very interesting, that if we just divide this 10 to the power n, then we will get, you know, it's 10 to the power n divided by 10 to the power n, which will be 1 minus 9 to the power n divided by 10 to the power n, which will be more simplifiedly, it will be 9 by 10 to the power n. Okay, so now if n goes big and big and big, the bigger number, then this will be much more. So the 9 by 10 to the power n will be tends to 0. So basically this number, which is kn plus 1 divided by 10 to the power n, which is the finding the probability, will become 1 minus 0, and then it will be 1. So basically 1. So basically if we just tend to calculate in the percentage, then it will be 100%. So that's what I want to share with you, that 7 is almost everywhere, but mathematically if we take the long range, if it's very very long, then obviously 7 is everywhere. And it's not only true for the 7, it's true for every other numbers, which is 0, 1, 2 and so on.